we're going to, it says use f of x is negative 2x, g of x is the square root of x, and h of x is the absolute value of x, to find and simplify expressions for the following functions. And we're going to talk about domain again. Domain is the set of all possible what? Inputs, right? Okay. So hold on a second. I'm back here at the top of the page. Now I'm off the map. Well, I want to look at those three functions. And I want to talk about what the graph looks like for each one. So let's talk about f of x is negative 2x. What does the graph of that function look like? If you know, sketch me a tiny graph. What's that? I'm sorry, Barb, go ahead. A downward sloping line, yes. How do you know it slopes down? You have a negative slope, right? Negative 2. So it goes through 0, 0. Do you guys agree that f of 0 is 0? Okay. And then if you go like down 2 and over 1, you might remember that idea. It's a line that looks something like that. Okay? So there's f of x. Now, I'm going to jump ahead to h of x because we just talked about this one the other day. H of x, it says, is the absolute value of x. And that's a good one to know about. Do we know what that graph looks like? Do you remember? It's a V, right? And so it goes through 0, 0. When I go in this direction, like it goes through 1, 1 and 2, 2, it has a slope of 1 in this direction. And it also has like a slope of negative 1 in this direction because the output is always positive. Because what does absolute value mean? Distance from 0. And so like if I put in negative 2, that's 2 away from 0. So it has to be positive. Okay. The one that you may not be familiar with is this g of x. So I want to talk about it just a little bit. The square root of x. That's an important class of functions. I'll tell you what, there's a whole chapter on this purple kind of function. All about square roots. There's a whole chapter, well no, there's half a chapter on linear. We're going to do that. It's chapter 2. They talk about linear and they talk about quadratic in the same chapter. What do quadratic look like? Parabolas, okay? Well, g of x being the square root of x, in some ways this is what's called the inverse function of a parabola. But anyways, let's talk about g of x a little bit. Give me an input and an output. Thanks. Input 1, output, because the square root of 1 is 1. All right. So I'll plot 1, comma 1 here. What else? 0. What's the square root of 0? All right. If I input 4, let's see. So there's 1, let's say, 2, 3, 4. What's the output? 2. The square root of 4 is 2, because 2 times 2 is 4. What if I input negative 4? You can't do that, right? We just talked about that in this class, right? So we're not, in other words, g of x is different than these other ones. If I were to talk about the domain of these guys, well, the domain of f is negative infinity, infinity, and the domain of h is negative infinity, infinity. But what's the domain of g? Yep, we can go to positive, and we can go any positive number we want. So we would say it starts at 0 and goes to infinity, right? Now, I don't know if you know what the curve looks like. I say it's a curve. The next point that you might know is 9, comma 3, all right? Or you might know if you input a quarter. You know what the square root of a fourth is? G of 1/4. I'm going to write that down. That's the square root of 1/4, and it's what? 1/2. How do people know that? Because a half times a half is a fourth. Or another way you can do this, and I will show you this more later, but you can split it up into square root of 1 over square root of 4. And so I get, what's the square root of 1 is 1. What's the square root of 4? See, that's a nice trick. You could split up square roots when there's a fraction. So, anyways, that's right here. The curve, well, it looks like that. And I should point out that what it really is half of a parabola. It's really half of a parabola. It's like the other half would be here, and then you'd have a sideways parabola. But when we write square root, we're only talking about positive number outputs. Because what would happen if you had this red curve here too? Well, then would this thing be a function? Because it wouldn't meet the vertical line test. So we only have positive outputs, okay? Anyways, I think all that's good to understand going into college algebra. Just kind of a basic function that we're going to work with in this class. So now I can go ahead and do some problems. I could do, for example, let's do 26 as an example. It says, give us an expression for H composed with F composed with G of X. That's what it asks me. And see, a lot of times what I do when I do composition is I do exactly this. I'll do several steps. And at first let's write down exactly what this means. And we're going to have way too many parentheses, but we'll deal with it. What would it be? It would be H of, and then what would I write next? F of, see, I'm putting those parentheses there, and then on the inside, what are we going to put? G of X, right? And I think, again, the easy way to do these is inside out. You can also go outside in, but I'm going to do inside out for my examples, other than the one I showed you before. All right, so the first thing we need to do is this G of X. What is G of X? Square root of X, yeah. So we're going to nest everything inside each other, right? Let's write everything down the way we did, but let's replace the G of X with the square root of X. So the only thing I've done so far is I'm going to replace G of X with the square root of X. So now I'm going to evaluate f of the square root of x. Is this okay? So let's see what happens. H of, we'll do that at the end. I want to compute what f of the square root of x is. Now remember, we know that f of x is negative 2x. So what do you guys think I'm going to write? Negative 2 square root of x. That's right, because we are inputting square root of x, not just inputting x like we did up there. Does this make sense to people? Okay? And so now my final step. Do you know what I'm going to do? Yeah, H says take the absolute value of the input. So we're going to write absolute value of what? Negative 2 square root of x. You guys understand? That's what you do when you do composition of three functions. Now I want to show you one more thing you can do here, which is you can simplify. And a lot of times we will. Now let's see if this makes sense to you. Do you guys think it'd be okay for me to write absolute value of 2 times the square root of x? Why? Yeah. And so what's it going to do? It's going to be positive no matter what, right? You guys follow that? As a matter of fact, I could simplify even more, I think. I could just write this. 2 times the square root of x. Isn't that true? Why? Well, what do we know about square root of x? Square root of x is always positive, just like absolute value. So it's almost like writing that absolute value is redundant. You don't need it. And so I might simplify this way. Now, one thing about simplifying that I want to be very clear about is this. Another thing we're asked to do on this problem is give the domain. When you want to give the domain of a composition of functions, look at the form before you simplify, because sometimes it makes a difference. In other words, don't look at the black. What you want to do is look at the red and ask yourself, what's the domain of that function? Now remember, the domain is the set of inputs that are possible. So when I look at it, I say, well, what's not possible? What is it that we're not allowed to put in for x? We can't put in any negatives, right? Now sometimes when you simplify, you'll get something that it looks like you could put in negatives. You have to kind of remember where it came from. So what would be the domain in this example? I guess I would list it as 0, infinity. Okay? That's the domain of h of f of g of x. 36 says we have r of x is 7 over x squared minus 1. I'm going to start off just by writing that down. So let's see. Problem 36. R of x is 7 over x squared minus 1. Okay, and what I'd like to do is come up with some functions that it came from. So I would propose that we write f of x is x squared minus 1. This is r of x, that's right. And you notice that here I wrote f. That's because this is a different function, isn't it? Okay? So what I'm going to do here is try to express r as a composition of f and another function, g. I guess the question is, can you come up with what the other function is that I'm going to do? I'll let you talk to someone about that for 30 to 45 seconds, or whatever else you want to talk about. What do you have? G of x equals 7 over x. If you do that, then another way to express the function r of x is to write it how? How do I put these two functions together, f and g, to get r of x? Yeah, so in other words, g of x is 7 over x, but we don't want 7 over x. We want 7 over x squared minus 1, right? So we don't want g of x. We want g of what? Well, x squared minus 1. Does that make sense to people? We want g of x squared minus 1. Do you see that? No? What's g of x? 7 over x. We want 7 over blah blah. 7 over cow. Right? So we want g of cow. What would g of horse be? 7 over horse. Right? G of x is 7 over x. G of cow is 7 over cow. Do you guys see that? It's funny how farm animals actually help. What is g of pig? See that? because it's 7 over, g of x is 7 over x. So, but what I want to get, what I'm trying to get in the end, I'll use red for r, is 7 over x squared minus 1. And I had, well, 7 over x. I noticed that if I put x squared minus 1 in for the x, that takes care of it, right? So what am I really putting in? When I write g of x squared minus 1, that's really g of what? What's another name for x squared minus 1 in this problem? F of x, right? We wrote down that f of x is going to be x squared minus 1. G of f of x. And so how do I write r of x as a composition? G composed with f of x. And then I would say, where, well, I have these guys. F of x is x squared minus 1. And g of x is 7 over x. And so I do have to say something about this function in number 36. R of x, that's complicated. Most people do not know what the graph looks like. And I even would have trouble myself saying, oh yeah, that's this kind of graph. I have to think for a minute. Because what it is it's several graphs that I am familiar with put together. Are you guys familiar with the graph of f of x? Raise your hand if you know what that looks like. Well, okay. I'm trying. This is done in chapter 2. It's funny, like the whole book is here on this one piece of paper. I'm telling you. Okay, let me go back to what's up top. These graphs we did today. Raise your hand if you're familiar with f of x. A few more people know what lines look like. Okay, that is done also in chapter 2. How about this absolute value of x? Raise your hand if you're familiar with that. That's also done in chapter 2. How about square root of x? You guys know what that looks like? Really? That's done in chapter 3. What about this one? Going way back down to this other g of x I just used. It was 7 over x. I don't know if you know what that looks like. But we'll cover it in chapter 4. So when I said that this course is a course in different kinds of functions, it really is. And then in the end, you can graph all kinds of stuff by composing the functions, putting them together. That's kind of what this is all about. Okay? So, anyways, I'm going to stop here. Composition of functions. Okay? And this is section 5.1. So what I want to do here is introduce a new symbol to you. Okay? And so the symbol is F circle G, where you have two functions. And I'm going to put those in parentheses like the book does. Sometimes these parentheses aren't here, but our book does that. Matter of fact, it's kind of like something else you can do with functions. What have we learned how to do with functions so far? Yep, we learned how to, I would call that evaluate them, right? You can substitute in a number. So for example, last time we found f of 0, and we also know how to solve f of x equals 0. Right, and so this gives us the intercepts, if we're thinking of it as a graph. What about if you have two functions? What have we learned how to do? Add, subtract, multiply, divide, right? So if I have f plus g of x, right, we learned that f plus g of x is the same as f of x plus g of x, okay? It's a way of combining two functions. And so for example, if f of x is x squared and g of x is 2x, as an example, but what is f plus g of x then? That's x squared plus 2x, right? I'm taking a parabola. If I'm thinking about the graph, that's what x squared looks like. What about this one? G of x equals 2x. If you were to graph that, what does it look like? It's a line, a straight line. Because g of x equals 2x, if I think of it as y equals 2x, I remember that that's the equation of a line. Now, if I don't remember that, that's okay. That's the first section of chapter 2. That's coming up again. You'll be reminded of that. But just for people that have seen this, well, you've all seen this before. It's a line. The y-intercept is 0. What's the slope of this line? 2 over 1, we say, or 2, right? Yeah, it's a slope of 2, so you rise 2 and run 1. We used to do this, okay? Fine. If you don't remember that, don't worry about it. That's coming in chapter 2. Okay? But my point is that I can combine the functions. Okay? Well, you can also do what's called a composition. This may be new to you. Okay? But it's a way of putting functions together. And what it means is f of g of x. Like that. Okay? So, in other words, when I write f circle g, f composed with g, I'm going to do, well, which function am I going to do first? Well, I guess g of x, because that's inside the parentheses. And then I'll take f of that. It's a way of putting two functions together. So, in this example here, where f of x is x squared and g of x is 2x, I could ask, what is f composed with g of x? Well, bless you. It's f of g of x. And I guess you have to figure out, how do you want to do this? One approach is what our author calls inside out. Let's worry about the inside and then figure out what happens with the outside. So what would you call the inner function? The inner function is g of x, right? So what I'm going to evaluate is f of 2 of x. Now how do you do that? Well, what's f of x? X squared. So everywhere there's an x, I need to put what? 2x. So f of 2x would be 2x quantity squared. I am squaring 2x. And so what do I get if I simplify? If we simplify, we're going to call that 4x squared. Okay? So f of g of x is 4x squared using this inside-out approach. Now, I can also evaluate it outside in. To me, this is less natural. But I'm going to go ahead and do it. See, it says f of g of x. That means I need to put g of x, how am I going to say this? Everywhere that an x is. Okay? So f of x is x squared. So what I'm doing is I'm going to say I am squaring not x anymore, but I'm squaring what? If it says f of g of x, I am squaring g of x, whatever that is. You guys follow? Of course, what is g of x? Okay. You're going to get exactly the same thing. Either way, f composed with g in this first example I did ends up being 4x squared. Okay? It's a way of putting functions together. Now, to give you some practice on that, I want to do a few exercises. And I mentioned that the first one I was looking at is page 371. Okay? So I'm going to zoom in a little bit so we can see these graphs a little better on page 371. These are graphs of two functions. I have y equals f of x, and I have y equals g of x. F and g. Okay? And I want to do, for example, number 57 is a nice example. Okay? So I need to look at that graph. So let's see. 57 asks me to compute f composed with g of 3. Okay? Well, what I do is I say, well, that is f of g of 3. All right? Now, I'll be honest with you. I am an inside-out person when it comes to composition of functions. It's how I think naturally. I guess my teachers when I was young always taught me, go from the inside of your parentheses and work your way out. So that's natural for me. So that's how I'm going to present this. I want to compute what first? G of 3. Now, to compute g of 3, I have to look at the pictures again because I don't have it here. I don't have any kind of a formula. But I do have a picture. And so on the right, when I look at the graph over here, what is g of 3? Now, it's right there, right? So what's the output when the input is 3? 0, right? So I'm going to go back, and where it used to say g of 3, I want to write what? 0. Does that make sense to people? So now I need to compute f of 0. And again, I'll have to go back to the graph, and let's see what we get. F of 0 would be what? Now, using this picture, it looks like it'd be 4. Okay. So f of g of 3 ends up equaling 4. You guys follow? Okay. I want to go to another type of problem that was in this book, and it's actually directly above on the same page, but you need to take a look because the directions are on the previous page, okay? So for example, I'm about to do number 51. I want to find g composed with f of negative 2, but I have to look at what we're talking about, where it says problem 51, g composed with f of negative 2. But let's go back to look at what the functions look like. Well, do you see the way they're listed? So f is right here, but it's listed as a set of ordered pairs. And g is a function also, but it's listed as a set of ordered pairs. You guys see that? It's not a graph. We had problems like this on the homework, and I had a lot of people leave them blank. Okay? So I thought, oh, I'll go over this today. And I want to do g of f of negative 2. All right, so what am I going to do? Well, first thing I'm going to do is I write g composed with f of negative 2 is equal to g of f of negative 2. Okay? What number is this? 51. Okay. Now, f of negative 2 is what I need to evaluate. I need to understand what the book means when they list these ordered pairs. See, remember, I want to go through what we've done in this class, okay? The first thing we did in Chapter 1, Section 1.1, I don't remember. But I do know that in 1.2, we covered something called relations. What are relations? I don't know. That was confusing. Most of you had never seen that. Relations are just sets of ordered pairs. And so when I list a set of ordered pairs like that, that's a relation between, say, x and y. But in 1.3, we started functions. And functions are special relations. Functions are a set of ordered pairs where each input has what? Yeah, exactly one output, no more. So for a relation, that doesn't have to be true. But I think that these are functions. They have to be if we're going to talk about composition. Anyways, I'm trying to compute f of negative 2. Well, you could tell that just by looking at the roster. What is f of negative 2? Do you see what I'm talking about? Right here. It says that when the input is negative 2, the output is 2. All right, so I can come over here, and I could say, well, this f of negative 2 is 2. So now I need to compute g of 2 to finish the problem. I'm going to let you guys finish that one up, and then we'll move on.